So in this video, we're going to talk about optimization. So Farmer Clark has 100 feet of fence, and he wants to make a pen for his chickens where one side of the pen is the side of a barn. Okay, so maybe it's a true story, maybe it's not. Bok, bok, right? Okay, so find the dimensions of a rectangular pen that maximizes the chicken pen's area. Got to have those free range chickens, right? So this is very similar to a problem that you work through in college algebra, where you find the vertex of the parabola with the negative lead coefficient, and works out great. Now I'm going to show you how to use this using techniques of the derivative and the first derivative test to find the vertex. All right, so let's work through this. First thing I want to do, I want to draw a picture. So I've got this barn. Okay, so here's my barn. I know that's a great barn there. And I'm going to draw a rectangular pen, okay, that maximizes the area here. Now, what do I know about this pen? I know that this pen has three sides because one of the sides is the barn, right? And I know that the fence is going to add up to, let me do blue here. The fence is going to add up to 100 feet. I know that to be the case, okay? Now, what I want is to maximize the area. How do I find the area of a rectangle? I do base times height. So x times y here for base times height. And what do I know? Once again, I know that the fence is 100 feet total. To get the perimeter of the fence, I just need to add all three sides. And so I have two x's, so that's 2x there, plus y, and then that equals 100 feet total of fencing, 100 feet total of fencing. So that's how we relate the two variables. Now, because I do not have multivariable calculus under my belt yet, I need to get rid of the two variables. I want to have one variable. I'm going to just stick with x here. And I need to rewrite y in terms of x. So I need to solve this equation for y here. How do I solve this for y? Well, to solve for y, I subtract 2x from both sides. And when I do this, I get y equals 100 minus 2x. Okay? So what does that tell me? The area function is x times y. But what do I know? It's x times, and then what does y equal? Well, y is equal to 100 minus 2x. So I'm going to plug that in right there. Now I'm going to take this and distribute. So I have 100 times x, which is 100x. And then I have negative 2x times x, which is negative 2x squared. So here's my area function, okay? Now remember, we are trying to maximize this function. This function is a parabola. Okay, so it's a parabola. So it's going to be maximized area. So the area is the number, the y value where it's maximized, right? Well, where's it going to be maximized at? Where the derivative, a prime of x is equal to 0, okay? So it's equal to 0, and we know that the derivative on the left side is increasing and the derivative on the right side is decreasing. That's the first derivative test, okay? So let's take the derivative of the area function here. So the derivative of 100x is 100. The derivative of negative 2x squared, bring the 2 down, negative 4x to the 1. Now, what do? I set the derivative equal to 0 and solve for x. To do this, I subtract 100 from both sides, negative 100, and then divide through by 4, okay? So negative 4x equals negative 100, divide by negative 4, and I have x equals what's a fourth of 100? That's 25. So x here is equal to 25. Now what I'm going to do is I'm going to use the first derivative test. I'm going to pick a point on the left side, and I'm going to pick the point on the right side. If I plug in 24 into my derivative, I have 100 minus 4 times 24. Okay, 4 times 4, that's negative 96, I guess. So minus 96. This is a 4, which is positive. If I have a positive input here, that means that I'm increasing on that interval. Now I'm going to pick a number bigger than 25, and that's going to be 26. If I plug in 100 minus 20, or 4 times 26, that's going to be 100 minus 104, which is negative 4, which is less than 0. So if I have a negative derivative, that tells me that I'm decreasing. So by the first derivative test, I have a relative maximum at x equal to 25. How do I know it exists there? Well, parabolas, remember, those are continuous for all real numbers, so x equal to 25 is a good to go relative max for us. Now, all that it amounts to doing, since I know x equals 25, I'm going to plug in 25 here, 25 here. Well, how many feet total did we have? We had 100 feet total. So if I had 100 feet total, I used 25 on this side, subtracted away, and I used 25 on that side, subtracted away. 100 minus 25 gets me 50. So that tells me y is equal to 50. The other way you could do this is plug it into your equation right here and plug in 25 for x, and you'll get 100 minus 50 again still. So this tells me that my rectangle that maximizes my chicken's pen so that they can be free-range chickens and taste better, right? Okay, so, sorry, getting hungry. All right, now, area. How do I I got the dimensions that maximize the area. So it says find the dimensions that maximize the area. Okay, great, we're done, right? But if I wanted to know what the actual area was, I just multiply base times height, and 25 times 50 gives me 1,250 feet squared. Not a bad house for a chicken.